Okay. See friends, now the basic thing in the probability is a random experiment. So what is a random experiment? Unpredictable outcomes of an experiment is a random experiment, friends. Suppose we have done an experiment. So in that experiment we are unable to tell what the output is. We cannot say exactly this is the output. That is, we are unable to say the exact output, but there is an output, we can imagine the output. See friends, that particular experiments are called random experiments. Example, tossing a coin. Do we know whether head or tail comes? We don't know at what particular toss, when head comes, when tail comes, we don't know. That is a random experiment. And second one, rolling a die. And in rolling a die also there are 6 outputs. We don't know what type of output will come, right? That is a random experiment. And another one, drawing a card from the pack of 52 cards. In 52 cards also, while we are drawing a random card out of that, we don't know what particular card will come, right? So there is an experiment was done, but we don't know what the output is. That particular experiments are called random experiments. Now see, sample space. What is a sample space? Collection of all possible outcomes of the random experiment is known as sample space. All possible outcomes. If I collect all the possible outcomes of the random experiment, if I keep them in a set, that is nothing but a sample space, friends. Okay, so sample space is denoted by capital S. These two are very important definitions. Next one. Okay friends, now very important definition, event. What is an event? Outcome of an experiment is known as an event. Whatever might be the output got from the random experiment, that particular output is called an event. Okay friends, so all these events can be, we will be keeping all these events in particular sample space. Okay, this is nothing but a sample space. This sample space consists of all types of events here. So in the set format, so every event is the subset of sample space. Fine. Next one, what is the probability definition, friends? Probability is always told to an event. Okay, probability of event is equal to number of favorable outcomes divided by total number of outcomes. It is nothing but it is a ratio of number of favorable outcomes to the number of total number of outcomes, right? Suppose P of E in the sense event, probability of an event equals to, suppose it is in the ratio m by n. M is always less than or equal to n, friends. When m is less than n, it is called as chance. When m is equal to n, it is called as certain. Sure. Okay, fine. So this is what the probability is. Fine, friends. So next one, very important, friends, rules of probability or axioms of probability. So first one is probability of sample space is equal to 1. Second one, probability of an event always lies between 0 and 1. Okay friends, it never goes beyond 0, it is not less than 0. Probability always lies between 0 and 1. Fine. So probability of an event is 0 is less than or equal to, probability of an event is less than or equals to 1. Next, third one, sum of all the individual probability of an events, P of E1, P of E2 plus P of E3, so on up to P of En. If there are n events, if I add the probabilities of every event, the value results to 1. That means sigma I is equal to 1 to n, P of Ei equals to 1. Fine. Next one. Fourth one, P of E equal to 0, it is called impossible event. P of E equals to 1, it is called sure event or certain event. That means the probability, if the probability is 0, it is not happens, it never happens. That means it is an impossible event, it never happens, right? Sun rising west, what is the probability? 0, right? Sun rising east, what is the probability? 1. That means impossible and sure event. Hope you understand. Fine, these are the main important axioms of probability. Now let us see the different types of events, friends. There are 3 types of events. There is a 4th type of event also. I will be telling you that also. First of all, see these 3 type of events. Dependent event in the sense, this is a sample space. This is the same trial. Two things are here. Occurrence of one event associating with the other event in the same trial, then those events are called as dependent events, friends. So these two are associated with each other. These two events are associated with each other. Remember. So in this case, in the event of dependent event, P of A intersection B is equal to P of A into P of B by A, or P of B into P of A by B. This is called conditional probability. I will be telling you that also. First you remember this. So example is drawing a card or drawing cards from a pack of cards. See friends, there are 52 cards. If I took a card, the next time when I am taking other card, that probability will be basing on this probability, right? Yes or no? It depends on this probability, because if 10 comes, the 10 of other red card or black card probability will change. So in the same way, that means pack of cards dependent on every card, right? Each other. So this is called as dependent event. Next, disjoint event. Disjoint event is also called as mutually exclusive event. Okay, mutually exclusive events or disjoint event. Here occurrence of one event, here this one, occurrence of one event prevents the happening of the other event in the same trial. Now suppose for example there is no association here, so there is a disjoint here. They both belong to same trial only but disjoint here. That means P of A intersection B is equal to 0. Fine. Tossing a coin is the example, friends. For example, when I am tossing a coin, if I get a head, that means it is preventing to happen tail. Right now, not when head comes, that is the absence of tail. Right? Head is preventing the tail to come. Right? In that way, so both are mutually exclusive. If it is tail, definitely it is not head. If it is head, definitely it is not tail. In that case, so mutually exclusive comes. Now, this is the heart of Venn diagram. Next one. Independent event. Independent event in the sense P of A intersection B is P of A into P of B. Simple, friends. There are two different trails. Suppose for example, on my right hand I have a coin to flip. On my left hand I have a die to roll. See, once you think of that, if I get 6 only, it will become head. Both I am doing at the same time. When it comes to 6 only, does it come head, right? No, it is not. It is both are independent to each other. That means if head comes only, I will come 6. Does it will tell? No, it won't. So that what does it mean? Both are independent to each other. Whatever might be the head or tail, whether it is 6 or not, it doesn't matter for it. Those two type of events are called independent events. For independent event, P of A intersection B is equal to P of A into P of B. Hope you understand these type of events, and remember these Venn diagrams. Venn diagrams are the heart of probability. Okay. So next one, friends, is small concept. Look at this. Suppose I have a trial. Suppose here there is an event A. The remaining part is nothing but not A, right? This is only A. The remaining is nothing but it is not A. A naught is nothing but A complement. So if I combine these two, can I get the entire sample space? Yes, I can. So combining means A union A complement is nothing but sample space. What is the probability? Apply the probability for this equation. So is nothing but P of S, right? What is P of S, friends? That is nothing but 1. So P of A union A complement is equal to 1. So these two are not interacted. That means P of A plus P of A complement gives the sample space probability, that is nothing but 1, right? So what is P of A complement, friends? 1 minus P of A. This formula is very important. We often use this formula in different sort of questions to solve, right?